BTEC Applied Science for AAQ, another chemistry video in part C, and this is about redox reactions. What are them then, Dave? Well, I'll tell you. There's a bit of a clue going on in the diagram there. So now we've talked about the valency. We know all about how the number of electrons in the outer shell affects the chemical properties. The oxidation state of an element, it's the charge that an atom would have if all of its bonds were fully ionic, which it's a bit long-winded, but basically what it's saying is that we know that sodium becomes Na+, so it has an oxidation state of +1. Magnesium becomes Mg2+ because it loses 2 electrons, so its oxidation state is +2. Why it's called oxidation state, we'll see in a bit. For the non-metals, they gain electrons, so chlorine becomes Cl-, so it's -1, and sulfur is -2, phosphorus -3, etc. Carbon and silicon, if they did actually form ionic bonds, then it would be either +4 or -4. They've got 4 electrons in the outer shell. They could lose all of them, or they could gain 4 electrons. Now, these numbers, one reason that they're very, very useful is for working out the formulae, the formula of compounds. If you look at this, can you figure out the formula for these compounds? You know, if lithium and chlorine got together, what would be the formula for lithium chloride? To me, it's pretty obvious. I think it probably is to you as well. Have a go, pen and paper, and I'll show you the answer in 3, 2, 1. So, LiCl. Each lithium loses an electron, each chlorine gains an electron, 1-to-1, LiCl. The magnesium, each magnesium loses 2 electrons, so you're going to need 2 chlorines for every magnesium, so MgCl2. Kind of the opposite thing with the sodium oxide. The tricky one is the aluminium oxide, isn't it? If every aluminium loses 3, every oxygen gains 2, then the equation is, well, if you had 2 aluminiums and 3 oxygens, then there's like 6 electrons involved, isn't there? So Al2O3. The other's pretty straightforward. The group 3 ones can be a little bit tricky, but I'm sure we can get used to that. Now, magnesium has an oxidation state of +2. Oxygen has an oxidation state of -2. So magnesium oxide is just going to be MgO. Now, I've done this balanced equation here. We need to double the magnesiums because oxygen's actually a molecule, O2. And we're going to end up with 2 MgO. So I've balanced the equation, but basically 1 magnesium, 1 oxygen atom, MgO. Now, in this reaction, each magnesium atom loses 2 electrons, okay? And each oxygen atom gains 2 electrons. We say that the magnesium has been oxidized. Now, not because it's reacting with oxygen, but because it's losing electrons, which is what happens when you react with oxygen and a few other things as well. Okay, so the magnesium atom has been oxidized, and that basically means it has lost electrons. The oxygen atom has been reduced, and that means it has gained electrons. So, oxidized and reduced. A redox reaction is one that involves electrons being transferred, okay? Usually from a metal to a non-metal, yes? So electrons, you know, the metal gives its electrons to the non-metal. Usually there are other redox reactions. The non-metal gains electrons, and we say it has been reduced, and then the metal loses electrons, and we say it has been oxidized, and that's why it's called redox, like reduction and oxidation. Why is it called oxidation and well, the name actually, it's historical. When people didn't understand this electrons being transferred stuff, you know, that's where the names reduction and oxidation came from. Don't worry about it. There's a very, very useful way of learning it, and that's OILRIG. Okay, OILRIG. Oxidation is loss of electrons. Reduction is gain of electrons. Okay, so your metals are oxidized and your non-metals are reduced. Let's look at this equation again. So magnesium and oxygen, magnesium oxide. Now, what we can do, in fact, what you need to be able to do is write what we call half equations. So the half equation, basically what's happening to the magnesium and what's happening to the oxygen. So if we look, Mg plus goes to Mg2 plus 2 electrons. So that's what's happening to the magnesium in terms of electrons. And then the O2 plus 4 electrons, because there's 2 of them, goes to 2 O2 minus. So half equations show what's happening to each of the reactants in terms of electrons. And then what you can do is combine the two half equations together to get the full equation, which is what we have already. Okay. Another example at the bottom there. This is for beryllium fluoride. Okay, so the beryllium atom loses 2 electrons. The fluorine molecule gains 2 electrons because each fluorine atom gains 1 electron. And so Be plus F2 goes to BeF2. So you have a go at this. Pen and paper, pause the video. Consider the reaction between magnesium and copper sulfate. So a word equation, magnesium plus copper sulfate goes to copper plus magnesium sulfate. We know that's a displacement reaction, don't we? So write an equation showing all of the ions involved on both sides. Okay, and there you go. So Mg plus Cu2 plus SO4 2 minus, that's the sulfate. Remember the polyatomic ions that you need to know and their charges, okay? And that goes to copper and Mg2 plus and SO4 2 minus. This equation shows all of the ions involved. What we can do is we can ignore the sulfate ions because they're on both sides of the equation and they don't actually do anything. We call them spectator ions because they're just looking on, not doing anything. So ignoring them, we end up with the equation at the bottom, and that's called an Ionic equation. Okay, here's one for you to have a go at. Calcium and carbonic acid goes to calcium carbonate. I'll give you a little bit of a clue. We know that calcium is in group 2 and the carbonate ion we know is CO3 2 minus, isn't it? Yeah. So write half equations for the atoms ions involved. Which ones are oxidized, which ones are reduced, and then write a balanced ion equation for the whole reaction, not including spectator ions. So have a go yourself. The answer in 3, 2, 1. There you go. So the calcium atoms are oxidized. The hydrogen ions are reduced. There's my ion equations, and I've not included the carbonates because they're on both sides.